Alright, y'all, let's go to section 4.3, which talks about independent events and conditional probability. Two events, A and B, are independent if the fact that A occurs does not affect the probability of B. So an example would be drawing a card from a deck, putting it back, and drawing a second. When two events are independent, the probability of both occurring is the probability of A and B. You notice A means to multiply. Alright, when the outcome or occurrence of the first event affects the outcome or occurrence of the second in such a way that the probability is changed, they're said to be dependent events. An example would be drawing a card, not putting it back, and then drawing a second card because the number of cards has changed. Alright, conditional probability of an event B in relationship to event A is the probability that event B occurs after event A has already occurred. The notation for that is the probability of B, that's, you say that given that A. Okay, if they're dependent, the multiplication rule 2 says the probability of A and B is the probability of A times the probability of B given A. And another formula for conditional probability is the probability of B given A is the probability of A and B divided by the probability of A. Okay, let's go to our book. Let's do a little practice and let's see how this goes. Okay, we're gonna be on page 222. So if you'll turn to page 222. And we're gonna start out with problem 1. All right, 1 says, state which events are independent and which are dependent. A says tossing a coin and drawing a card. Those have no effect on each other, so those are independent. Okay, B, drawing a ball from an urn, not putting it back, and then drawing a second. Okay, that's dependent because you didn't put it back. C, getting a raise in salary and purchasing a car. All right, those are dependent because you probably wouldn't have purchased that car if you didn't get that raise. D, driving on ice and having an accident. Those are dependent because probably driving on ice would have caused that accident. All right, let's go to 3. 3 says 69% of U.S. heads of household placed video or computer games. Choose 4 heads of household at random. Find the probability that A, none play video or computer games. All right, you've heard something called the complement, which means if like it's an 80% chance of rain today, there's a 20% chance it wouldn't rain. That 20% chance is called the complement. So what I need to do then, if 69% are going to play, subtract that from 1, and I made it a decimal, that means that 0.31 or 31% would not have. And we've got that happening 4 times. First head of household, second, third, fourth, or in other words, I can write it that way. So 0.31 to the 4th power, if you punch that in your calculator, is 0.009. Okay, 3B says all 4 do. Okay, if you go back up there and read, it said that, I'm sorry, y'all, this should have been a 69, not a 67. all four do, so that's gonna be 0.69 4 times, or 0.69 to the fourth, which if I punch that in my calculator, I get 0.227. Alright, let's move to 5. Alright, 5 says, an automobile salesperson finds the probability of making a sale is 0.21. If she talks to 4 customers, find the probability that she will make all 4 sales. Okay? The probability that she'll make one of the sales is 0.21, and we want to know if she's going to make 4 of them. Okay, so that's 0.21 to the 4th, which is 0.002. The question also asks us, is this likely or unlikely? Well, since that's so small, that's actually going to be 0.2% chance of that happening, so this is unlikely. Alright, moving on, let's go to the next page, page 223, and let's do number 11. Alright, 11 says, in 2006, 86% of U.S. households had cable TV. Choose 3 at random. Find the probability that A, none had it. Alright, so if 86% have it, I'm going to subtract that from 1, which is going to be 0.14. But this time, it only wants 3 of those. So I'm going to do 0.14 through the third, which is decimal 003. Okay, 11B says all 3 had cable TV. So that's going to be 0.86 to the third, which is 0.636. And now C is a tough one. This is a special case which talks about at least. If you want to refer back in your book, there's some examples on page 220, but I'm going to write 3 little steps that you have to find, or that helps me out, okay? The first thing I do is I find the complement. Okay? The second thing I do is I raise it to whatever power I'm given. And then step 3, I subtract from 1. Alright, so when I do letter C right here, it says at least one of the 3 had cable TV. So the first thing I'm going to do is find the complement, which was 0.14. And to find the complement, I subtract. Okay, so there's my complement. Raise it to the power, or it's talking about 3 households. So I'm going to raise it to the third, which we've already done, and we got 0.003. And then lastly, to find the at least 1, I subtract that from 1. And my final answer would be 0.997. Alright, we'll do another one like that before we stop. Let's jump to 13. Okay, 13 is talking about cards. 4 cards are drawn from a deck without replacement, so these are dependent events. Find the probability. A, all are kings. There's 4 kings. I don't put that card back, so there's 3 kings out of 51 cards. I don't put that back, so there's 2 out of 50. And then one more draw, so there's 1 king out of 49. Okay, I'll multiply all those numerators, denominators, This is a big nasty decimal. It's decimal 1, 2, 3, 4, 5, 3, 7. Okay, 13B. 13B says all are diamonds. There's 13 diamonds in a deck, 52 cards. I don't put that back, so the probability of another diamond decreases 1, and then again, and then a fourth diamond. Those nasty ones like that, I make those decimals, so that's 0.003. Okay, C. C says all are red. Okay, there's half of the deck is red. You don't put it back, so it decreases 1 each time. Remember, these are called dependent events. Okay, punch all that in, multiply it all together, make it a decimal, so it's 0.055. Alright, next thing, let's talk about some conditional probability. So let's look ahead to number 23. Alright, 23 says, for a recent year, 0.99 of the incarcerated population is adults, and decimal 0.7 are female. If an incarcerated person is selected at random, find the probability that the person is a female. Given that means to divide, the person is an adult. So I'll take the percentage that's a female, and I'm going to divide it by the percentage that is an adult. If you look back at your notes now, that's the formula for conditional probability. Okay, I punch that in, divide it, so that's 0.071. Alright, let's jump to 27. 27 says, at a large university, the probability that a student takes calculus and is on the dean's list is 0.042. The probability that a student is on the dean's list is 0.21. Find the probability that the student is taking calculus. Alright, well that percentage is 0.042. Given that means to divide the student, hold on, I've lost my place. The student is on the dean's list is 0.21. Another example of conditional probability, which is 0.2. All right, let's finish out this section. Let's do number 35. Only 27% of U.S. adults get enough leisure time exercise to achieve cardiovascular fitness. Choose 3 adults. Find the probability that A, all 3 get enough. So that's going to be 0.27 to the third. And now B is the one I really wanted to zero in on. That's another one of those at least problems. B says at least one of the 3. So the first step we wrote a while ago was to subtract and find the complement, which is 0.73. Raise it to the power, and then subtract from 1. Okay, so the final answer is 0.611. Okay, if you got any questions, let me know.